Hi guys. Okay, so now we're going to look at the algebra and functions section, which is the second AS topic. So what I suggest you do, these are obviously all available on the Edexcel website, is actually attempt them first, because it's a lot, it's more useful to you to then work through them after that, but you know, maybe it'll help you learn it as well. Again, excuse the fact I am in my bedroom and it's a little bit of a mess, but hopefully that shouldn't really affect this. Right, so we've got using a factor theorem. So again, I know you could divide it and show, you could do your long division and you show that there are no, there's no remainder, but that's not using the factor theorem. The factor theorem states that if something is divisible by something minus a, f of a equals 0. Meaning, if here in this case we've got it's divisible by x minus 5, it means that the root is 5. So we need to show that g of 5, so substituting 5 in, gives us 0. So we're going to do 2 times 5 cubed plus 5 squared minus 41 times 5 minus 70 equals 0. Now you don't really need to plug that in, you know that's the case, you're trying to show it. And you say, you know, let's take rid of that actually, and then you can just say, this shows x minus 5 is a factor, hence gx is divisible by, you have to write the sentence even though you've just used the factor theorem here. And now it says show all your working, meaning don't just plug it into your calculator. We know you can plug a cubic and get the roots from your calculator, but they want you to show your division. I do long division very differently from how well, not very differently from how the textbook does it. I'm an examiner, I mark exams, it's totally acceptable. I think it's easier. Obviously, if you've learned division in a different way and that works for you, stick to how you do it. This is effectively the same, but in a line. So if I wanted to divide this by x minus 5, what I would do is I would say, well, what's the biggest factor? It's cubed. So therefore, I'm going to write x minus 5 3 times. This is only because when I do long division the other way, my brain sometimes mixes things up. So this is what works for me. So I'm going to say to myself, what do I multiply x by to give me 2x cubed? Well, that's going to be 2x squared. And then all I do is I open the brackets. So 2x squared times x gives me 2x cubed. If it doesn't give you the first term, you've done something wrong, double check. And then it gives me minus 10x squared. So I'm saying to myself, well, I have minus 10x squared, but I want plus x squared. So that means I've got to add another 11. So I'm going to add 11x. And now I'm going to open the brackets. Do I get plus 11x squared minus 55x? And then I say to myself, well, now I've got the plus x squared. I want minus 41x. I have minus 55x. So I know that I need to add an additional 14. And when I do that, I get plus 14x minus 70. And I've done my division. So essentially this shows that I've got x minus 5 multiplied by all of these bits, 2x squared plus 11x plus 14. If you had done it going down, you'd have got the same answer. It's whatever works for you. So 2x squared plus 11x plus 14. And then it wants you to factorize it completely. Now, if you do plug it into your calculator, you just substitute into your calculator, you go to menu, go to equation, cubic, and it will give you your roots as being minus 2 and minus 7 over 2, which means you can instantly factorize that because you know one of them is x plus 2. You can go, that must be 2x plus 7. And you've written it now as a product of 3 linear factors, 1, 2, 3. Okay, next question. Find using algebra all real solutions to the equation. Okay, so instantly I look at that, some of it's in indice form. And root A is not in indice form, so step one, I'm going to put it into indice form. So when I do that, I get 16a squared equals 2a to the power of a half. Now, what we could do is divide both sides by 2. 8a squared equals a to the half. I could put all the a's on one side. So a squared divided by a to the half equals 1 over 8, which will give me a to the 3 over 2 equals 1 over 8. In my calculator, I do shift square root and put the 3 over 2 as the other side, and I get a as a quarter. Now, this would only get you 3 out of the 4 marks because you haven't taken into consideration that a equals 0 is also a solution. So whenever you divide by a function, you've got to think about it. So if you like, the proper way to see that would be to put everything on one side. So you could have taken it at this point here. I could have put everything on one side, taken outside of the bracket the common factors or the smallest factors, and then I would have ended up with 8a to the 3 over 2 minus 1. And then I could say this equals 0, which leaves me with a equals 0, or this equals 0, which leaves me with the a quarter. It doesn't really matter. It's just, or you just remember when you divide by a function, so not just a number, see if a equals 0 works or x equals 0 works, and that's your missing solution. Okay, here we look at this and straight away we can see we've got a disguised quadratic. So we take whatever's in the middle. Don't worry about the last number. You look here and you take this here, and that's what you let, say, your x equal. So we're going to let x equal b squared. So we're going to get x squared plus 7x minus 18 equals 0. We can factorize that. X and x. 18 is 9 and 2, and we're going to get plus 9 minus 2. So x equals minus 9, x equals 2, which tells me b squared equals minus 9, b squared equals 2. It's illegal here in maths to take the square root of a negative number. It gives us an imaginary number, which you're not going to worry about right now. And so we go, okay, that's not, or you could just write not valid underneath. And you take the square root of 2, and it's square root 2 or minus root 2. Don't forget the negative. Whenever you take a square root, you've got your positive and you've got the negative. Okay, next question. Oh, a graph one. Okay, so a lot of my students look at graph questions and they're like, we don't like them. These are gift questions. So the way that you're going to remember any of the transformations of things, inside the bracket affects the x's. X's are like ex-friends, ex-partners, ex-boyfriends, girlfriends. They do the wrong thing. So the x's inside the bracket are doing the wrong thing. So if it says +1, it's really -1. If it's -1, it's really +1. If it's something inside the bracket multiplied by 2, you're really taking the coordinates and dividing it by 2. The only time this doesn't really apply is if it's just a minus or as a minus, then there isn't an opposite, if you like, to that, you just flip it. Okay, so we want the coordinates of the turning point. What's the turning point? It's where it turns. So it's your minimum point. So in this case, it's your M. Okay, and we've got outside the bracket. Outside the bracket are great. They're the Y's, they do exactly what you want them to do. You know, nice and happy. So outside the bracket, we've got a 2. So we look at the y coordinate, which is the -1.5, and we double it, which is nice and easy. Nothing's happening to the x. So the coordinates of the turning point are just going to become, for the x stays the same, -3. And it says state the largest root of the equation gx + 1. So inside the bracket affects the x coordinates. So we want the roots, which means we're either looking at P or Q. And we are, instead of adding one to them, we're minusing one from them. So we just want the largest one, minus 1, and that's just going to be 6, 0. State the range of x for which g dash x. So g dash x is just a fancy way of writing the differential. Now, what does the differential tell us? It tells us the gradient. So if I think about this curve, it's the gradient function. Everywhere we're going down the slope, so if I was to draw a tangent, all of these would be negative tangents over here. And all of here would be positive tangents. So we know that until, so if I take, say, so from here all the way down to just before here, it's sloping downwards. If I was drawing a line, I would end up with a negative line. Whereas, all the way up here, it's sloping upwards. If I was to draw tangents, I'd end up with a positive line. So we want the values of x for which the differential is less than or equal to 0. So if we have a look, that's the yellow bit. So all we're going to do is we're going to say the range of values for x, and it's equaling that as well. So we can include the 4, is x is less than or equal to 4. And it says, given that an equation gx plus k, so outside the bracket affects the y's, plusing it, so it's moving upwards. So we want to move it upwards until it no longer touches the axes. So we want to move it up. If we move it up 1.5, it would still have one root because it'd be sitting there. But anything above that, it will have no roots because it's sitting above the axes. So we would just say k has to be bigger than 1.5 because we're moving it up 1.5, so it sits above. Right, next question. Scroll too fast. Okay. Solve the equation, writing the answer as a surd in the simplest form. Right. So before you even start this question, you've been told to write it as a surd. There's two ways you could do this. You could try simplify the root 18 first, which is probably what I would do. So I'd take this and I'd say, well, root 18 is the same as 3 root 2, which your calculator will tell you, but you should really recognize it's the same as root 9 times 2. So root 9, root 2, so 3 root 2. So we've got x root 2 minus 3 root 2 equals x. If we were solving this like as an algebraic function, put all the x's on one side. So x root 2 minus x equals 3 root 2. Move the 3 root 2 to the other side. Take x outside the bracket. We get root 2 minus 1. Divide both sides by root 2 minus 1. So we get 3 root 2 over root 2 minus 1. And then remember, we don't want surds on the denominator. We just don't like them there. So we're going to rationalize the denominator. So we're going to multiply top and bottom by root 2 plus 1, at which point I put it in brackets so I don't get confused with the signs. And when I open that up, I get 3 root 2 times root 2, which is going to give me, so root 2 times root 2 gives me 2. So I end up with 3 times 2, so 6, plus 3 root 2 over square of the first. So I've got 2 minus 1, which is just 1. So my final answer is simply 6 plus 3 root 2. And that is your answer as a surd in the simplest form. It doesn't have to be one thing. A surd can be a real bit plus a surd, like a whole number plus a surd. Right, solve the equation. Okay, it's only 3 marks. If you find yourself going in circles with something like this, you've probably not done it right, I need to have a look again. So what I'm going to do is I'm going to write everything as a factor of 2. So I know that, actually, let's make this a bit bigger. All right, so I know that 4 is the same as 2 squared. I'm going to have 2 squared and all of that, and then I've got 3x minus 2. I know that this bit here is the same as 1/2 times 1 over root, right? Because you times the top and times the bottom. Now, 1/2 is the same as 2 to the power of minus 1, and this is 2 to the power of minus 1/2. So I've got 2 to the minus 1 times 2 to the minus 1/2. So that gives me 6x minus 4. And here I can add the powers because I'm multiplying. So it gives me minus 3 over 2. Now, because the base bits are the same, I can just equate these two. And that makes life easier. So I get 6x minus 4 equals minus 3 over 2. And so x equals 5 over 12. Okay, next question. Oops. So in the new spec, they like to do these things where they say, oh, there's an error somewhere. And it depends how your brain works. Sometimes the error is such a way that you're like, and you can't see it. So sometimes it's actually easier to take the question and do it and then compare it to what they've done. But let's see if we can work through it and see the logic. So we've got from here. All right, now hopefully straight away, you appreciate that that does not equal that, because you need a multiply sign to add indices. So my first answer, my first mistake, I can say, I don't know, in line 2, 2 to the 2x plus 4 should be 2 to the 2x times 2 to the 4. And then we go through and we assume what they've done is correct at this point now. So we get y squared minus 9y plus 8. Okay, that looks correct. 2 to the x. 2 to the, wait, actually, maybe not. 2 to the 2x, so they've replaced that with y. So we get y squared minus 9y. Okay, 2 to the 4 is not 8. So we'd say in line 4, you've got to assume now that their logic is correct, where they've gone wrong, and you're trying to find the next mistake. So in line 4, 2 to the 4 does not equal 8. 2 to the 4 equals 16. Right, so now let's do it properly. So to find the exact solution. There's 2 ways to do this. You can do it using logs, or you can do it using a disguised quadratic. So let's do it using the disguised quadratic. So we're going to say, well, we know that this is the same as 2 to the 2x multiplied by 2 to the 4 minus 9 to the 2x equals 0. So 2 to the 4, we know 16. So we're going to let y equal 2 to the x. So we're going to get 16y squared minus 9y equals 0. Take a common factor outside, so take y outside. 16y minus 9 equals 0. Y equals 0, or y equals 9 over 16. But y is actually 2 to the x, so 2 to the x equals 0. 2 to the x equals 9 over 16. An exponential can never be 0, so we're going to say not valid. We'll put a cross through it if we want. And here we're going to say we want an exact solution, so we're going to take logs. So this is the same as, x is the same as log. This is your base to the base 2, 9 over 16. Because essentially, you always have the base to the power of whatever equals. So that's how you convert back from logs. And that's your exact solution. Okay, Oh, it's another graph question. Like I said, these are nice questions. Right, so to start with, use the factor theorem. So this is your nice easy bit. Remember, we're going to say if x plus 2 is a factor, if x plus 2 is a factor, then we want to look at g minus 2. So we're going to do 4 times minus 2 cubed minus 12 times minus 2 squared minus 15 times minus 2 plus 50. It's telling you it's a factor, so you're just going to write equals 0. G to the minus 2 equals 0. Therefore, x plus 2 is a factor. Okay. So that bit's nice and easy because you're using your factor theorem. Hence show that gx can be written in another form. So again, we've got to do the division bit first. I'll show you again how I do it. Like I said, if you do it a different way, not a problem at all. So x plus 2, I'm going to write this out 3 times. And I'm going to say to myself, how do I get 4x cubed? I'm going to do 4x squared, open out the brackets, 4x cubed plus 8x. So I've got 8x, but I want minus 12. So that means I've got to minus another 20x. 20, so it's minus 20, minus 20. I'm so sorry, that should be an x squared. So minus 20x squared. So now I've got my minus 12x squared, and then I end up with minus 40x. I don't want minus 40, I want minus 15. So this will become plus 25. So plus 25x plus 50, I know I've done it right because it all balances out. And I'm left with x plus 2, and then whatever's here, 4x squared minus 20x plus 25. Yeah, that's right. Yeah. Okay, and now this goes back to what we just did in the proofs one, if you watch that one. And if I want to take this and I want to do it an exact square, all I do is I take the first value, I square root it. It gives me 2x. The last one, I square root it. And then I say, will a plus or minus, what's in the middle? There's a minus there, so that needs to be minus. And you can open that out and double check that you've done that right. So now we can see we've got one root, which is x equals minus 2. And we've got x equals 5 over 2. Because it's squared, it's the bit that it sits on. So we know this is going to be minus 2, and this is 5 over 2. Let's scroll up and stick those values into the graph. So what we just found out was that this is minus 2 and this is 5 over 2. And now they're saying, deduce the values for which the graph is less than or equal to 0, for which gx is less than or equal to 0. So it equals 0. So this is my y values. So if I was to pick a y value anywhere, an x value anywhere between here, every single x value would give me a positive y value. Well, no. Only, even here, everything's going to give me a positive y value. The only place I'm going to get a negative value is after this point here. So that's when x is less than or equal to minus 2. But because when we've got equals 0 as well, we can't forget x equals 5 over 2. Now we've got 2x. Inside the bracket affects the x's. The x's do the wrong thing. So instead of doubling, they half. So we're taking our 2 roots and we're halving them. So minus 1 and 5 over 4. Right, next question. Factorize completely. Okay. you won't generally be expected to do a cubic that doesn't just have x as one of its factors. So what you're going to do here is take x outside the bracket, and you're going to get x squared plus 10x plus 25. And hopefully you recognize it like an exact, or you could do it as 2 and you realize you end up with x plus 5 squared. Sketch the curve showing the coordinates where the curve cuts or touches the axes. So whenever we're sketching a graph, we say, what's the plus c? In this case, it goes through the origin, because when x is 0, y is 0. And then we have, okay, so what are my roots? We've got x is 0, and we've got x is minus 5. But at minus 5, it just hits it either at the top or the bottom. So the way you'd go about sketching this is you'd go, okay, so I know I've got something happening at minus 5 and something happening at 0. Right. It's a positive x cubed. So I start low, end high. So just think about a positive. If I was to put together both ends, so if I was to take both ends of the graph and join it, I want a positive line. So the only way to do that and sit it on here is to touch it here, go right, bump, and then up, because we know it just has that one root where it bumps. If I try to go through that, it's not hitting on it and it's not starting low. Sorry, I don't know why that's disappeared. Okay. Then we've got the point with coordinates minus 3, 0 lies on the curve with this equation. Find the two possible values. So it looks strange, but actually you can see that all that's happened is everywhere there's an x, it's replaced by x plus a. So the whole graph has been shifted to the left or the right. We don't know whether that a is positive or negative, but we want it to go through minus 3. So either that minus 5 has shifted to minus 3, or the 0 has shifted to minus 3. If the minus 5 has shifted to minus 3, the a must be minus 2, because remember, it's always the opposite. So we could have minus 2 there. If it has shifted to minus 3, then the a must be 3. So that's all it's asking you to do. You just have to think about it. How has it shifted? It's inside the bracket, shifting the x's. However I think it shifts the x, I have to then, so if I think about this, this has shifted minus 2, therefore in the bracket, this has shifted plus 2, so therefore in the bracket, it's minus 2. This has shifted minus 3, so then in the bracket, it's plus 3. That's probably a better way to understand that. Okay. Right, we've got the curve. Sketch C, stating the equation of the horizontal asymptote. Okay, so if I have a look at that, k is just a constant. So whenever I have anything, any constant over x, so you should know the graph of y equals 1 over x. It's one of the ones that you recognize, looks like that. Now, if in terms of sketching it, I mean, the gradients will be different, but if that was 5 over x, 8 over x, 108 over x, that is still your sketch. You're still sketching it like that. But now what have I done to that 1 over x or whatever over x graph? I've shifted it up by 1. So in a regular 1 over x graph, your horizontal asymptote is y equals 0. You shift it up 1, it becomes y equals 1. So what you end up happening is you get a graph. You've got y equals 1, that's your x, that's your y, and you just shift that graph up by 1. Then we get told the line L has an equation minus 2x plus 5. That's nice. Show that the x coordinate is given by the solution. Okay, so we've got a line that goes through somewhere here, so 5. And so we're essentially making them equal to each other. So we've got k squared plus over x plus 1 equals minus 2x plus 5. Right, hate things on denominators, get rid of them first before you try sort even numbers out. So I'm just going to multiply everything by x. And so that gives me k squared plus x equals minus 2x squared plus 5x. They've put the 2x squared as positive, so we're going to move everything on the left-hand side. 2x squared, x minus 5x gives you minus 4x, plus k squared equals 0, which is what you want. Hence, find the exact values for which L is a tangent. Now, if it's a tangent, it's not going to cut through like that. It's just going to meet in one place. So that means the discriminant, so remember the discriminant is your b squared minus 4ac is going to be 0. So although this says algebra and functions, we've also got quite a lot of coordinate geometry in here. So here a equals 2, b equals 4, minus 4 even, and c equals k squared. So b squared minus 4ac is going to be minus 4 squared, so 16 equals 0, minus 4 times 2, so 8k squared equals 0, 8k squared equals 16, so k is plus or minus the square root of 2. So those are your two exact values. Exact values you can't just plug into your calculator. Okay. Right. Equation kx squared plus 4kx plus 3 equals 0. Okay, so no real roots. So again, we've got a discriminant. So we know that b squared minus 4ac has to be less than 0. So my a is whatever's in front of the x squared. My b is whatever's in front of the x. And I would always write this out. It takes only a few seconds. I know you know it, but in an exam especially, brains go to fudge. And it's very hard to check things or look for it later. Whereas if you stated it, you can then find it if you think it hasn't worked or you've done something silly. So b squared, so 4k squared minus 4k times 3 less than 0. So we get 16k squared minus 12k less than 0. K outside the bracket. 16k minus 12 less than 0. So if that was equals 0, we get k equals 0 and k equals 12 over 16, which is 3 over 4. But we want one that's less than 0. When we think about that as a quadratic, that's going through there and 3/4. The place where the x, the y's are going to be less than 0 is this bit in between. But also they've told you in the answer. So you can just give the answer, right? So you've got those two options. You know k equals 0 also will give no real roots because it's where it goes through. So you can just straight away go to, well, therefore this is the case. Now on your calculators, you have an inequality button. So you can use that as well and check it to make sure your solution is correct. Okay. Right, we've got a graph, it's upside down. We look at that and we go, oh, they've put it in negative completed the square form. So without even reading the question, I'm looking at that and going, oh, well, this tells me because it's in this form, straight away, I know what this point's going to be. This point is going to be whatever makes the bracket 0, so 9 and 100. Right, now I'm actually going to read the question. A company makes toys. The profit is measured in thousands of pounds. That's really important. And the other one's in pounds, because it might not make sense if we do something. Explain why 15 is not a sensible price for the toy. Well, let's see. When x equals 15, p equals 100 minus 6.25, 15 minus 9 squared. So that's going to give us minus 125, which doesn't make sense, not sensible. as company makes a loss. Given that the company made an annual profit of more than 80,000. Now, this was, I think, the 2018 paper. I can't remember anyway. But I know when we marked it, this was one of the questions I had to mark in the exam. The amount of people that made the profit equal to 80,000 and didn't recognize it was thousands of pounds caused them to lose marks. And you could, I know in an exam, that's why these sorts of things are important. Read the question, underline things like this. So we're going to, it's in thousands of pounds. So we're going to make the P equal to 80, right? And I know it's saying more than, but that just means we round it up when we're trying to find the least possible price, right? And then we're going to solve that. And because it's in completed the square form, we don't need to open out the brackets. We can just move this onto this side. 100 minus 80 gives you 20. Divide by 6.25. So that gives you 3.2. So x equals 9 plus or minus the square root of 3.2. We want the minimum price. So we're going to do 9 minus 3.2. And that gives you 7.21, because we want it to be more than that, we round it up. So x equals £7. So 7, okay, so your two solutions, let's put those in the calculator properly, gives you x equals 7.22, 7.2, okay, it gives you 1111, dot, 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 or you get 10 point something, but we want the minimum, so we're going to stick with 9 minus, but because it's money, we have to do it to 2 decimal places. Because we want more than, we round it up as opposed to down, so we get £7.22. The company wishes to maximize. Now that was the work we did at the beginning. You know, when we saw it and completed the square form, when we went, the maximum is, you know, 9 and 100. But remember, the profit is in thousands. So straight away we write 100,000, and the selling price for that was £9. I think that's the final question. Yeah, that's page 14. So hopefully that's been useful. Leave me a comment, let me know if not, or if there's, I'm going to try work through all of these before the end of half term. They're not neat, you know, it's a bit all over the place, but the idea is, so for those of you in AS going into A2, let me actually get rid of this so I can see your faces. In AS, going into A2, I'm going to be working quite hard over the summer and putting together sort of like a mini course, which each of the snippets with then having lots and lots of exam questions, because the best way to do maths is to do the questions. Now, unfortunately, a lot of the textbooks and a lot of things that you do at school, there's this big jump from like the questions and then the exam questions. So what we'll try to do is take a topic, me yap, hopefully for not too long to keep your attention, and then go through exam questions, starting with easy ones, going to harder questions. So that's going to start running from sort of July onwards, and I'll try to do something a little bit more structured. And if you're interested, subscribe, and then hopefully it'll beep at you. Otherwise, I'll update which ones I'm doing which week on other social media, so on TikTok mainly. I don't have the attention span for anything longer than that generally. I hope this is useful. Ignore the yapping, and yeah, I'll do the next one.